in which angle B is twice of angle C. Okay. D is a point on BC such that AD bisects this is D, AD bisects angle BAC. So that means, and AB equals CD. So this AB equals CD and AD bisects angle BAC. So that means this angle will be equal to this angle. So if this angle is X, then this angle is also X. We have to prove that. So what all is given to us? AB equals CD, angle BAD is equal to angle CAD. Then, one more thing is given. Let's say if this is Y, if this angle is angle Y, let's call it angle Y, and this is twice of Y, right? It's given in the question that angle B is equal to twice of angle C. And what else? Yeah, that's it. That's all that is given. So let's do one thing. Now we have to do a construction. We'll have to do a construction. Let's take a line segment such that this angle is getting bisected. So let's take a line segment. Let's say this is P such that this angle is equal to this angle. So let's say this. So if this is being bisected, that means this will be Y and this will be Y, right? Because this entire angle was 2Y. So then this will be Y and this will be Y. Okay. So construction. Let BP be the bisector of angle ABC. Okay. Now we need to show that angle BAC is 72 degrees. So now one more thing we need to do here. We'll have to join PD. Okay. We have to join PD. Now, in triangle BPC, we have angle CBP, this one. Why? We're talking about this triangle, just a minute. Triangle BPC. Yes. And we can see that these two angles are equal to each other. If these two angles are equal to each other, that means this entire side will be equal to this entire side, right? So angle CBP is equal to angle, what is this? BCP is equal to Y, right? That means these two sides, BP and BC, will be equal to each other because the reason is sides opposite to equal angles in a triangle are equal. Okay. So this is one thing. Now let's look at this triangle, the above triangle, triangle ABP. Okay. Triangle ABP. In this triangle also, we have AB is equal to, so let me just make a slight change here. I should not have, so let's do this. 2, 1, 2, 3. So now in this triangle, in triangle ABP, and let's say in triangle ABP, the green one, and triangle DCP. Let me make it different color. this pink one, okay, in triangle ABP and triangle DCP. We know that angle, this angle here, this angle is equal to this angle. Yes, angle ABP is equal to angle DCP is equal to Y. Then AB is equal to CD, this is given. And also BP is equal to PC. Sorry. Okay, because these both are equal, we proved here, shown above. Okay, write it till here. Hmm. So in these two triangles, triangle, therefore, triangle ABP is congruent to triangle DCP by which rule? SAS. Okay. Now, therefore, if they are congruent, therefore, angle BAP. So let me show you what these two triangles look like. This one and this one. So here, this one is equal to this one. This side is equal to this side. And this angle is equal to this angle. So therefore, by CPCT, we will have this angle, angle BAP, this one will be equal to angle. So this is A, B, P. This is P, D, and C, right? Yes. So if triangle ABP is congruent to triangle DCP, so which will be the corresponding parts? A will correspond to D. Okay, so these two angles will be equal. So angle BAP is equal to angle CDP. And also the third side will be equal. AP is equal to DP by CPCP. Okay, write it till here, then we will move forward. So now, how much is BAP? Angle BAP, as we can see, it is equal to 2x, right? Angle BAP is equal to 2x. So that means this angle, angle CDP, is equal to 2x. And angle ADP, which is this one, is equal to angle DAP, which is this one, which is equal to x. Okay. So since this since AP is equal to DP, so remember this, CDP is 2x. This is 2x. Okay. Now look at this triangle. ADP. We have here proven that AP is equal to DP, right? If AP and DP are equal, that means opposite angles will also be equal. That means this angle will be equal to this angle. And since this angle is x, so therefore angle ADP is equal to x. Okay. So that means this angle is x. So now see this triangle. Therefore, in triangle ABD, we have triangle ABD means this one. In triangle ABD, this is ABD. Okay. See, this angle over here is 2x plus x, which is 3x, right? So the exterior angle here is 3x. And this one is x and this one is 2y. So that means by exterior angle property, by exterior angle property, 3x is equal to x plus 2y. That means now take x to the other side. 2x is equal to 2y. That means x is equal to y. Okay. If x is equal to y, then you can clearly see in the biggest triangle, this one, the original triangle. In triangle ABC, what will be the angles if you apply angle sum property? Add all of the angles of the triangle. 2x plus 2y plus y, right? So it becomes 2x plus 2y plus y equals 180 degrees. But x is equal to y, right? So 2x plus, this is what? 2y plus y is 3y. And 3y means 3x because x and y is the same thing. So that means 5x equals 180 degrees. That means x equals 180 by 5. That means x is 36. But angle A is twice of x. So angle A is 2x, which is 72 degrees, hence proved. So let's just go through this again. So what we did first was we did some construction. We knew that this is given to us, angle B is twice of angle C. So this is given as twice of this angle. So we did a construction where we made an angle bisector, and hence this angle became y and this angle became y and this angle is also y. Then we said let these two angles be x and x. And because this was given that this angle BAD is equal to angle CAD, so we said it is equal to x. Okay. Now, first we took in the triangle BPC. This triangle BPC. Okay. In this triangle, what we did, we said that, well, this angle is also y and this angle is also y. So if these two angles are y and y, they're both equal. So this side should be equal to this side. So that means BP is equal to PC. Now, when we took the green triangle and the pink triangle, I know it doesn't look like that in the figure because it is a very rough figure. So in the green triangle and the pink triangle, which look like this, over here I've drawn them separately. Angle ABP is equal to angle CBP, right? Look at these two. This angle is also y and this angle is also y. Then AB is equal to CD, it is given. This side is equal to this side, it is given. Then BP is equal to PC, we have proven this. Now, since these two triangles are congruent by SAS, therefore by CPCT, we have these two angles are equal. And also, A, the third side will also be equal. AP will be equal to DP. Now, if you look at this triangle, triangle APD, AP is equal to DP. That means these two angles should also be equal to each other. So that means this angle is X. So this one should also be X. That means now we saw in this angle BAP is angle CDP. BAP means what? This one and this one are equal. But BAP is 2x, right? So this one is also equal to 2x. So from here we got this one. Now in triangle ABD, by using exterior angle property, we got x plus 2y equals 3x, exterior angle property. From here we got x is equal to y. Now then we applied angle sum property in the entire triangle and we got x is equal to 72 degrees. You can note this down. Okay, so which chapter do you want to revise next? Yes. Students, which chapter do you want to revise next? Okay, fine. Let's do quadrilaterals. Hmm. Do you have any specific doubts, or do you want me to give questions?
I have one doubt.
Okay, go ahead.
In a quadrilateral ABCD, comma,
Hmm.
angle A plus angle D is equal to 180. What special name can be given to this quadrilateral?
Hmm. We know we have just done the circles chapter, right? We know that if there is a quadrilateral in which sum of opposite angles is 180, then this is called a cyclic quadrilateral. Okay. Any other question? You guys have any other questions? Okay, let's do this one. This is a very common question I've seen asked in exams. This is there in the NCRT also. So you have ABCDs at trapezium, in which AB is parallel to CD and AB is equal to BC. No, AD is equal to BC. Prove that. This is there in NCRT. So you must have done it, but let's revise it quickly. A, B, C, D. Okay. This is equal to this. So in this, we need to do a construction. Construction. Well, it's just this. Extend AB to a point E such that A, no, such that CE is equal to BC. Okay. So P such that C is equal to BC. Now, see, since these two sides are equal, that means if this angle is X, then this angle will also be X. That means in triangle BEC, angle BC is equal to EC from construction. Therefore, angle CBE is equal to angle CEB. And we know that this is the property of angles in isosceles triangle. I'm not going to write it again. Okay, but in your exam, you have to write it. Okay, so is equal to X, say, is equal to X, say. Now, if this is equal to X, then this angle over here. Now, this angle over here, angle ABC plus angle EBC is 180 because they form a linear pair. That means angle ABC is equal to 180 minus angle EBC, which is x. So your angle ABC is 180 minus x. Okay. So this is 180 minus x. And you need to do this in your diagram, in the figure in your exam paper, so that it's easier for you to keep track of what's happening, and for also for your teachers to know that the student knows what he or she is doing. Okay. Now, now since AECD is a parallelogram. Why is it a parallelogram? Because AE is parallel to CD, and also opposite sides are equal. Okay. And also AD is parallel to CE. Okay. Since AECD is a parallelogram, therefore adjacent angles are supplementary. We know that in a parallelogram, adjacent angles are supplementary. So that means angle A plus angle E is equal to 180. And that means angle A is 180 minus angle E, which is x. That means angle A is also 180 minus x. So clearly from 1 and 2, angle A is equal to angle, or you can say angle DAB is equal to angle ABC is equal to 180 minus x. Or you don't have to write 180 minus x. Hence proved. Okay. And in the NCRT, there is another part of this question, but we'll do it only till here. Yes, it would be a lot easier for all of us if you guys could bring questions, some doubts. Looks like you people don't have any doubts at all. See, if you don't have any doubts, that could only mean one of two things. Either you know everything, you're very confident in the topic, you don't have any doubts at all, or it is that you haven't studied anything. So when you study, you get doubts. Okay, let's do this one. ABCD is a parallelogram and angle DAB is 60. This is 30, this is 30, this is 60, this is 60. Okay, here you have to show that P is midpoint of CD. So see what all is given to us. We know that these two, this one, AP and BP are angle bisectors. That's what we know. And you can check one thing. So angle A plus angle B is 180 degrees, right? Because these are adjacent angles of a parallelogram, so they have to be supplementary. So if in the question it was only given as this one is 60 and this one is 60, so we can then clearly say that this one has to be 30 and 30. Anyway, let's move on from here. Mm-hmm. We have to prove that P is the midpoint of CD. Now, if you look at the fact that this is a parallelogram and AB is parallel to CD, these two lines are parallel to each other. And if you consider AP as a transversal between them, AP is a transversal, then angle PAB, this one, will be equal to angle APD, right? Because this is a alternate interior angles, alternate interior angles. So this one is going to be 30, and similarly this one is going to be 60. Okay, so let's write it here. Since AB is parallel to CD and AP is transversal, therefore angle DPA is equal to 30 degrees since alternate interior angles. Okay, similarly angle CPB is 60. So now if you look at triangle APD, you have this is 30, this is 30. If there are two angles which are equal, this is 30, this is 30. So this side should be equal to this side. Yes. And similarly, if you look at this triangle, you have two angles which are equal to each other. This is 60 and this is 60. So now what we have shown here is in triangle APD, AD is equal to DP. Why? Because sides opposite to equal angles are equal. Okay, this is equation number one. In triangle CBCP, CB or BC is equal to CP. Again, same reason. But we know that since this entire thing, ABCD is a parallelogram, so AD is equal to BC. So AD is equal to BC. That means DP should be equal to CP, right? So from 1, 2, and 3, AD is equal to BC, or let's say it like this, DP is equal to AD, and AD is what? It is equal to BC because of this, and BC is equal to what? CP. So that means DP and CP are equal. If DP and CP are equal, that means P is the midpoint. That means P is midpoint of CD. Okay, let's do another question. Here you have a parallelogram. It's a bit different. The bisector of angle A also bisects BC at X. This is A, B, C, D. So this is angle bisector. That means this angle is equal to this angle. Okay, and this is X. Let's call this angle 1 and let's call this angle 2. What is given? Angle ABCD is a parallelogram. Then angle DAC is equal to angle BAC, meaning these two angles, this one and this one, are equal. And the other thing is given, which is this portion is equal to this portion, meaning CX is equal to XB is equal to half of BC. To show that AD is twice of AB. Okay, now let's come to the solution. Since this is a bisector, you can say that this one is equal to half of angle DAB. Okay, this is given. Now let's see one thing. Since this is a parallelogram, so angle, this angle plus this angle is 180 degrees, right? So since this is a parallelogram, adjacent angles are, so angle DAB plus angle CBA is 180 degrees because adjacent angles of parallelogram are supplementary, meaning they add up to 100. So that means angle CBA is equal to 180 minus angle DAB. Angle DAB. Okay. Now in this triangle, this is 180 minus, let's call DAB as angle A, okay? Or let's do one thing. Let's call this as X and this as X, small x, or we already have an X over there, so let's call it as Y, okay? Small y. This is small y. Hmm? So this is 180 minus small y. No, 180 minus 2y, because DAB is 2y. So this is 180 minus 2y. So we can find out from here angle, this angle over here. Okay. So in triangle ABX, from angle sum property, we have y plus 180 minus 2y plus angle AXB is 180 degrees. This 180 get cancelled. Okay. And so therefore angle AXB is equal to 2y minus y, which is y. So that means this angle is also equal to y. Now if this angle is equal to this angle, that means in this triangle, therefore AB is equal to BX. We know that if the two opposite angles are equal, matlab two angles in a triangle are equal, then their opposite sides are also equal. Okay, so the same thing, the same reason which we have used many a times. Now AB is equal to BX, right? And BX is what? BX is half of BC. Half of BC. So AB is equal to half of BC. That means if you take the 2 to the other side, twice of AB is equal to BC. But BC, this side is also equal to AD because it's a parallelogram. So twice of AB is equal to AD since it's a parallelogram, opposite sides are equal. So this is what we needed to prove. AD is equal to twice of AB. If you don't understand anything, please feel free to ask. Okay, I hope you're done. Now, let's do another question. Hmm, all of these questions are already from NCRT, so we've already done it. Want to do something new? Just a minute. Question number. Okay, let's do this. P and Q are points of trisection of the diagonal BD of a parallelogram ABCD. So there is a parallelogram ABCD. See, bisection means divide something into two equal parts. Okay. Trisection means divide something into three equal parts. So if this is x, this is x, this is x, and the whole is 3x. Okay, that is called trisection. So they're saying P and Q are points of trisection of the diagonal BD. So this is the diagonal BD. Points of trisection, meaning one point is here, one point is here, and they're all equal. So P and Q. Prove that CQ is parallel to AP. Okay. So this is CQ and this is AP. also prove that AC bisects PQ. So AC bisects PQ, meaning you have to show that this is AC bisects PQ is a very simple one. We won't be doing that. AC bisects PQ means you have to show that. Acha, PQ. Fine, we'll do that also. I thought AC bisects BD. So let's make AC. Okay, let's call this O. Okay, so these are the points of trisection. So what all is given? ABCD is a parallelogram. DQ is equal to PQ is equal to BP is equal to, all of these are 1/3 of BD. Okay. And what else is given? That's it, right? To show that CQ is parallel to AP. First of all, we'll show this, and then secondly, we'll show that secondly wala we'll do later. Okay, right now I don't think we have time for the second one. Let's just do the first part. CQ is parallel to AP. So now, since we know that diagonals of a parallelogram bisect each other, right? We already know this. So since diagonals of a parallelogram bisect each other, therefore OA will be equal to OC. This part will be equal to this part. And similarly, OD will be equal to OB. And OB is equal to OD. Hmm? Since P and Q are points of trisection, therefore BP equals PQ equals QD, which is given. Now, look at OB. OB is equal to OD. Yes, we have just written that. And also BP is equal to QD. This is given. BP is this much and QD is this much. So if you subtract this, that implies OB minus BP is equal to OD minus QD. So that means OB minus BP is how much? OB minus, oops, OB minus, this is OB and this is BP. OB minus BP is OP. So OP is equal to OQ. This is what we needed to prove. We have proved it first. You had to show that AC bisects QP or PQ. So this is what we have shown. AC bisects PQ. We have shown that OP is equal to PQ. Fine. This is shown. Now the next part. Let's do one thing. Yeah, so OP is equal to OQ. And see one more thing, this quadrilateral over here, let me color it. The quadrilateral APCQ, this quadrilateral. In this quadrilateral, it has two diagonals, right? One is, let me just redraw this. Two diagonals. One is PQ and one is AC. So we already know that this diagonal BD, bisects AC. So that means AO is equal to OC because it's a parallelogram and we know that the diagonals of a parallelogram bisect each other. So AO is equal to OC, which we've already written here. So since AO is, now look at this parallelogram. Therefore, let me call this 1, and let's call this as 1 and this one as 2. So from 1 and 2, diagonals of quadrilateral APCQ bisect each other, right? When we are saying that AO is equal to OC and we are also saying that OP is equal to OQ, that means diagonals of this quadrilateral bisect each other. And if diagonals of a quadrilateral bisect each other, that means that quadrilateral is a parallelogram. That means APCQ is a parallelogram. And since it is a parallelogram, that means CQ is parallel to AP, which we needed to prove. Okay. So that's it for today's class.